Hello, everyone, and welcome to our webinar hosted by Shimadzu Scientific Instruments in collaboration with our partners across different countries in the Americas. My name is Ruth Marfil Vega, and I'm the co-host of this webinar with my colleague Keith Long, and we'll be presenting about total organic carbon and total nitrogen, and we are going to be presenting about new solutions for these old contaminants. Before we start, I wanted to share a couple of notes for our viewers. The webinar console has a variety of items to help you with the experience in this event and interact with us. In the screen, you'll see the following items. The slides will appear on the left-hand side of the screen. Directly under the slides, you will see a resource list with clickable links relevant to the material that we are going to be presenting today. On the top middle is the widget for questions and answers. Please submit your questions during the presentation through this window, and we'll answer them at the very end of the webinar. And we can see that the Q&A is already working and seeing the questions that are coming up. Just below the Q&A box are the moderator and speaker bios. You may expand the items there to learn more about us. On the right-hand side, there is a survey with a few questions that you might fill out at any time during the presentation. Finally, at the bottom of the screen, you'll find the icons to bring up all the widgets I mentioned about, in case you minimize them or they get hidden. With that being said, we have lots of information to share with you about total organic carbon and total nitrogen. So let's get started. I would like to reintroduce my colleague, Keith Long, the product support lead for total organic carbon analyzers here at Shimadzu Scientific, who will be our main speaker today. Now I will hand it to Keith.
Thank you, Ruth. And thank you, everybody, for joining us today for our presentation, Total Organic Carbon and Total Nitrogen, so new solutions for these old contaminants. So in today's webinar, we will learn the benefits of Shimadzu TOC systems and how they will help your lab to ultimately save money. So we will learn today how to increase productivity with a combination of robust hardware and Shimadzu's all-new LabSolutions TOC software. So this is designed to save you money. We'll also learn how you can expand analysis capabilities for samples in difficult matrices, including high suspended solids, high salt, and high halogen concentrations. Once again, these are designed to save your lab even more money. And finally, we will talk about how you can replace traditional Total Kjeldahl Nitrogen, or TKN measurement, with a safer, faster, and more accurate instrumental analysis, all designed to save your lab even more money. So first, we're going to talk about Shimadzu's lineup of TOC instruments. So as you can see in this slide, we offer a wide variety of TOC instruments to suit every application. On the bottom, you can see we do make online analyzers. These samples range in measurement from ultra-pure applications using our TOC 1000E for samples like semiconductors, pharmaceutical applications, and then we have our TOC 4200 online analyzer for the higher level stuff, from drinking water, environmental samples, all the way up to wastewater samples. Now, these analyzers are designed for online, means they're in-process analyzers. So at the top, you will see our lineup of benchtop laboratory analyzers. on the left, you have our TOC-VW, which is a wet chemical analyzer. So these types of analyzers are very good for low-level analysis like semiconductor, pharma, even drinking water. And on the right, you have the TOCL, which is pretty much going to be good for everything else. Some pharmaceutical applications, more drinking water, environmental, and even wastewater samples. So today's webinar is really going to focus on this guy, the TOCL combustion analyzer. So as you can see, Shimadzu TOCL is the global standard for TOC analyzers. It is a combustion analyzer because it uses high temperature catalytic oxidation and an NDIR, or non-dispersive infrared detector, to measure carbon. We also offer a whole lineup of different options to meet almost any application or any sample type. So, the versatility of the TOCL combined with our all-new LabSolutions TOC software will help your lab to increase productivity. Now, the TOCL has a lot of advantages. First of all, it ensures complete oxidation of all sample matrices, even difficult or hard to oxidize samples, because it uses a furnace temp in excess of 680 degrees C and platinum catalyst. It also has auto-calibration features and intelligent dilution capabilities. We have comprehensive method capabilities and integrated software for data integrity and security of your data. We also offer many different configurations and many different accessories to meet all lab needs. So recently, Shimadzu introduced its brand new LabSolutions TOC software. So the LabSolutions TOC software now includes data management functions for full traceability of all data collected, including metadata and all your audit trails. Now, all this information is saved in secure databases, so this will prevent accidental deletion or even tampering of the files. The software also has functions for reviewing the data and signing off on the data files. So LabSolutions TOC is the software that is used for controlling the TOC and collecting the data. It is now integrated into the larger LabSolutions Manager software. This software can collect and manage data from a variety of other instruments and keep all that data information in one location. The major benefit to this is that all administration functions are located within the common LabSolutions Manager software. This makes it really great for administrators and even auditors because they no longer need to know the TOC software. They simply need to know how to use LabSolutions Manager, and that can be used for all the instruments connected to the system. So the LabSolutions TOC software has many great features. One is it has easy-to-use user management functions. This is for creation of user rights in the software, and these can be based on personnel level. For example, your role or in the lab, or your job in the lab, or it can be even for individual accounts, so on an individual basis. We now have backup and restore functions that are easily found and located in the software. The data, as well as audit trails, can be backed up. So in the event of a disaster, the work environment can be restored quickly and easily, and without any additional software. And one of the coolest features, I think, is this new report set function that is integrated into the software. We all know how important it is to protect data, but it is equally important to ensure the traceability of the data. Therefore, our software now includes this all-new report set function that can create reports linking the measurement data with all the related audit trails. So this feature will greatly increase efficiency because it streamlines the process of matching up the data with all the related audit trails and keeps everything in one central location. Now, the LabSolutions software has many great features, probably too many for me to list here. So we have compiled a short list of the features we think are the best or most beneficial. So these features are designed to make running the instrument easy for even the most inexperienced user. So we have things like automatic remeasurement of over-range samples. So this is for samples that are over the range of the calibration curve. So when this happens, the instrument can recognize it. It can go back, apply a dilution factor to your samples, and rerun your samples so that now your measurement results are within the range of your calibration curve. It has the ability to create a multi-point calibration curve by automatic dilution from one high standard solution. This is a great feature because it allows you, A, to only have to have one standard solution, so it saves you a lot of time and money. You're no longer having to prep all your standards. We have built-in methods for very common tests like the USP, EP, and JP. Those are, for people who don't know, USP is United States Pharmacopoeia, EP is the European Pharmacopoeia, and JP is the Japanese Pharmacopoeia. The instrument also has the ability to add samples and edit the sample sequence on the fly. So this is really cool. So if people come into your lab and have priority samples that need to be run on a moment's notice, the sequence does not need to be stopped in order to do this. You can simply pause the instrument, add those samples, and continue right on with your analysis. The data can be easily exported and/or imported for connection to LIMS systems. The software also has an integrated background monitor window in the software. So this is cool because it allows for real-time viewing of all instrument parameters. So if any parameters are out of spec or no good, the instrument will not allow you to start measurement. This ensures that all data collected is good data. And another cool feature is automatic shutdown. The automatic shutdown mode allows the instrument to run unattended, and then it can shut itself off when the sample sequence is completed. You can also, instead of shutting the instrument down, have it go into a sleep mode. This is a function where you can tell the instrument to wake back up. So in the case of maybe you're coming in the next day to run samples, you can have the instrument wake up at a certain time so it is ready and warmed up when you get to the lab to run samples. Some other cool features that we have are a mechanical check function. So this is a window in the software that allows you to go in and check all mechanical functions of the instrument. So this is very useful for troubleshooting any mechanical issues should they arise. Now we have quality control templates can also be created for check standards and even spike samples. Pass-fail criteria can be entered into the software so that when you run samples, a pass-fail notification will be included in the sample table. This is for quick and easy recognition of whether or not your checks pass or fail. Additionally, actions can be associated with these controlled samples or templates. So upon failing samples, the instrument can be triggered to do certain actions. So you could have the instrument stop. You could have it go back and rerun that failing sample. You could even tell the instrument to go back, rerun the calibration curve, and start your analysis over from the beginning again. Or very simplistically, you could just have the instrument notify you upon the failure and continue on. So these are all cool because it turns your instrument into what I would consider a smart instrument. Now, we also have customized methods, calibration curve, and schedule files that can be created and saved in the software for future use. Reports can be easily customized to only display the desired data that you want to see. There are ability to save multiple different hardware configurations within the software. Now, this is designed to accommodate all the various options and different accessories that can be added onto the TOC. And we will go through a lot of these in the next few slides. Additionally, there is a real-time display of the detector outputs. So this can be very useful in troubleshooting issues and seeing the real-time output from your detector to determine maybe if there are issues. And finally, the software comes standard to comply with 21 CFR Part 11 regulations. This is with no additional charge or even no additional software for the customers to purchase. So probably the biggest advantage of the TOCL combustion analyzer is its ability to handle even the most difficult sample matrices, including suspended solids, high salt samples, and even high halogen samples. The instrument, because it's a combustion analyzer, offers a very large detection range. We can detect carbon up to 30,000 milligrams per liter. Also, one of the big advantages of the combustion analyzer is it does not require very large injection volume. A typical injection volume is anywhere from 50 to probably 200 microliters. So what this means is that less sample being injected equals less waste that users have to deal with. The high oxidation potential of the high temperature furnace and the platinum catalyst also ensures complete oxidation for even the dirtiest or most particulated samples. Salts and solids will be trapped in the combustion tube, so it is ideal for wastewater and even high salt, high halogen samples. And when combined with our optional TNML total nitrogen module, it is possible to measure total nitrogen and total organic carbon simultaneously with one injection of sample into the instrument. So many labs, even today, are still required to measure and report BOD, or biochemical oxygen demand. BOD values indicate the amount of oxygen needed for biological decomposition of organic compounds dissolved in water. It is commonly used for the evaluation of treatment processes and the assessment of pollution load to a receiving body of water. Now, this presents many problems because BOD test takes 5 days. Many times labs don't have 5 days to wait for results. Additionally, sometimes a microorganism cannot kill all the organics present in the sample. And even some extreme cases, toxic materials in the water can kill the microorganisms. So for this reason, many labs choose to run TOC. What you can do is measure TOC and BOD and then establish a relationship between the two analyses. So then what that allows you to do is once you establish that relationship, labs can then run TOC, calculate the TOC number, and then multiply it by that relationship or the factor and calculate and report the BOD values. So this is a great advantage because the TOC test takes 4 to 5 minutes, while the BOD test takes 5 days. Now, many labs also have high sample loads and are always looking for ways to run more samples faster. So Shimadzu offers ASIL Auto Sampler, which can be used with our TOC analyzer. It has various vial size options to meet all labs' needs. We have 40 ml vials, 24 ml vials, and 9 ml vial rack options. Now, the larger size vials are used for low-level analysis, because larger volumes are needed for the lower level analysis. So conversely, the smaller size vials are used for the higher level analysis because you don't need large injection volumes when you're doing a higher level analysis. Additionally, switching to the 24 and 9 mil vials can increase your throughput from 64 vials all the way up to 93 vials. Now, additionally, we offer an external sparge kit. This kit is installed on the autosampler to even further increase throughput. And the most common type of analysis that most people are running is NPOC analysis. So when performing NPOC analysis, or non-purgeable organic carbon, samples need to be sparged to remove the inorganic carbon from the sample prior to measurement. Now, the external sparge kit, as seen in this picture, simply adds a second needle to the autosampler for the sole purpose of sparging head vials on the autosampler. This will in turn reduce the overall time required to run a batch of samples compared to the standard configuration of sparging the samples internally in the syringe inside the TOC. So as you can see in this picture, the needle on the left will be in the sample vial, measuring, say, sample number 1, while the second needle on the right is down in vial 2, sparging a head vial 2. So in this manner, it just proceeds through your sample rack. And this will in turn, like I mentioned, increase throughput because we no longer need to wait for the sparging to occur inside the TOC. Now, it's also very common for environmental samples to contain large amounts of suspended particles. And for this reason, Shimadzu has many optional kits that can help you deal with these kinds of very difficult sample matrices. First of all, we have an optional stirrer kit for the autosampler. Now, this is a kit that uses a bank of magnetic stir motors installed underneath the carousel. There will then be a knob on the side of the instrument that can be used to adjust the rotation speed of those stir motors. So the idea is you drop little bitty stir bars in each vial, and when that vial is rotated around the carousel to the measurement position, the little stir bars will start stirring the sample in the vial, so that when the needle goes down into the vial to pull up a sample, we are always pulling in a homogeneous aliquoted sample for measurement. Now, please note that this kit is only available for our larger size vials, the 40 ml and the 24 ml vial sizes. Now, second, we offer specialized autosampler needle and autosampler tubing. So what this autosampler needle and tubing do is it increases the inner diameter of the needle and the tubing from 0.5 millimeters to 0.8 millimeters. So what this does is it will decrease the likelihood that particulates will be pulled in that can clog any of the flow lines in the instrument. And third, for samples that have particularly high sedimentation rates, such as algal samples, we have a specialized high suspension kit. So this kit actually changes the injection sequence of what the instrument's doing so that sample is now pulled into the syringe, then in one motion directly injected into the TOC or the combustion tube for measurement. This means there is no time for the sample to settle in the syringe or the flow lines where sample could possibly settle out, causing biased sample results. Now, do keep in mind that this kit is different than the suspended particles kit that we just talked about in the previous slide. So it's also common that many wastewater and environmental samples tend to contain very high levels of salt and even halogens. These types of samples are much better suited for combustion analyzers compared to wet chemical oxidation models, because halogens will interfere with the wet chemical reaction in those analyzers. Now, the salts or the halogens in the samples will not interfere with the combustion analyzer. They will, however, tend to lead to increased maintenance. as the salts will build up. So this means that there will be more downtime for an instrument, and more downtime means your lab is losing money when the instrument is not running. So now there's nothing that users can do about the salts. If they are present in the samples, there's nothing you can do. So what Shimadzu has done is we have designed a unique high salts kit that utilizes a newly designed combustion tube, as seen on the right in this slide, and a new catalyst packing using larger bead platinum catalyst and smaller bead platinum catalyst. This is all designed to trap the salts on top of the catalyst, preventing them from melting or working down into the catalyst where they can cause issues such as blockages in the combustion tube, or even devitrification of the quartz combustion tube itself, which could lead to breakage of the tube. Now, lots of salts generally means there are lots of halogens present in the samples too. Now, halogens, specifically the chlorine ion, can cause damage and deterioration to the detector cell if they're allowed to pass through the system to the detector. So for this reason, we need scrubbers to remove these halogens. Shimadzu has designed and offers this new B-type halogen scrubber. This scrubber is designed to remove large amounts of halogens that would be generated when running samples with high salts or high halogen loads. And many labs and methods will also specify using sulfuric acid to acidify samples for NPOC analysis. Now, generally, if you look in our manual, Shimadzu recommends hydrochloric acid because we have the halogen scrubbers in there to remove the chlorine. So now if you switch to sulfuric acid, you will need to add additional scrubbers to remove these sulfuric acid vapors. In similar fashion as halogen, these sulfuric acid vapors, if allowed to make it to the detector, can cause damage to your detector. Additionally, they can cause interference with measurement. This is because SO2 exhibits a very similar absorption band, very close to that of CO2. So it can be interpreted or measured as CO2, leading to biased high results. So for this reason, Shimadzu offers an additional scrubber to remove the sulfuric acid vapors. So this scrubber is meant to be used in conjunction with the typical halogen scrubbers for protection of your detector. So what does this really all mean? Well, it means that labs that routinely run these types of samples can utilize these three options: the high salt kit, the B-type halogen scrubber, and possibly the SO3 scrubber, or a combination of these three to significantly increase the number of samples you can run before you need to perform maintenance. So as you can see in this table in this slide, we took a 28% sodium chloride sample, spiked it with some organic carbon, and just ran that sample repeatedly. And as you can see, we made it up to 600 injections and still were able to produce results that were consistent and repeatable. So this just shows you how these samples or these kits can help you prolong, say, the life of your combustion tube. Now, we can also handle solid samples. So for measured solid samples, even samples that are too thick or viscous for the TOCL, we offer the SSM 5000A solid sample module. This is an optional accessory, and it uses a much hotter furnace at 900 degrees C for combustion of solid samples. It also uses a combustion tube in there with platinum catalyst similar to what is found in the TOCL. Additionally, it has a separate side on the right and a slightly cooler furnace at 200 degrees C for measurement of inorganic carbon in the solid samples. Together, these two measurements can be used to calculate the total organic carbon content in the samples by a simple equation that total carbon minus your inorganic carbon will give you the organic carbon content of your samples. Now, measuring samples with the SSM 5000A can be slow and time consuming because there are little weigh boats that you use. You weigh your sample in those weigh boats, and then you have to put that weigh boat in the instrument or that ceramic boat and push it into the furnace. Now this is all manual, so it's very labor intensive for users. So what we have done is we have developed a method where you can take these samples, like soils, for example, and you can disperse them into water, and you can homogenize them to create a suspension. What this allows you to do is then you can use the TOCL and even the ASIL auto sampler to measure these samples. So you can run more samples faster, thus increasing the throughput of these samples. Now, as you can see in the table on the right, we did a comparison study. So we took some samples, some soil samples, and we measured them on the SSM with a direct combustion method, so directly measuring them with the SSM solid sample module. Then we took those same soil samples and did a suspension method, as we call it, where we took those samples, put them in some water, homogenized them so we created a suspension and measured them with the TOCL. And as you can see, the results we obtained were very similar, indicating that for these types of soil samples, that you can actually measure them using the TOCL and increase the throughput of samples. Now finally, many labs don't have a whole lot of sample volume to work with. So for these types of samples, we have some different options. As we already talked about, we have the auto sampler and we have a 9mm vial rack. So using that vial rack combined with our small sample volume kit, we can measure samples using less than 9 mils of sample. So this small sample kit just swaps out the normal 5mm syringe in the instrument for a 500 microliter syringe. So this in turn means less volume of sample pulled in, less volume of sample needed to rinse flow lines, meaning we can get away with using a lot less sample for measurement than with using the traditional kit and the 5mm syringe. Now we also have something we call the manual injection kit. So this kit is for the measurement of extremely small volumes of samples and even gas samples. So the kit utilizes manual valves that are installed in place of the automatic injection system, allowing you to use a gas-tight syringe, like the one pictured in this slide, to pull up sample and then manually inject it into the combustion tube for measurement. So because of a gas-tight syringe, you could even use liquids, but you could also measure gas samples if needed. Now, Shimadzu TOCL has the ability to add on an optional TNML or total nitrogen module. This can be used to measure total nitrogen in samples, offering a safer, faster, and more accurate method compared to the traditional Total Kjeldahl Nitrogen or TKN analysis. So why is it even important to measure nitrogen? Well, first of all, nitrogen is a critical nutrient required for all life. And excess nitrogen can be bad because it can stimulate algal blooms. So some sources of excess nitrogen that we need to worry about include fertilizers, wastewater, animal waste, and even atmospheric deposition. So first, to understand all this, we need to understand the different forms of nitrogen found in water. First of all, the EPA definition of total nitrogen is TKN plus nitrite plus nitrate. TKN can be further defined as organic nitrogen plus free ammonia. So the classical TKN method, which was developed by Johann Kjeldahl in 1883, is still being used today. Now in concept, water samples are digested at the boiling point and a concentrated sulfuric acid and potassium sulfate solution in the presence of a metal catalyst. So theoretically, at temperatures in the neighborhood of 370 to 380 degrees C. Any organic nitrogen compounds are converted to ammonium ion. The converted ammonium ion, together with any ammonium that was present in the samples, are either distilled, diffused, or determined directly in the acid mixture, depending on the method being used. So this method is very labor intensive, not to mention dangerous, and generates lots of hazardous waste. Additionally, some forms of organic nitrogen are not fully recovered, and in extreme cases, biased results have been reported for samples containing nitrates. So Shimadzu's solution is to use the TNML total nitrogen module to measure total nitrogen. This method is quick, about 4 to 5 minutes per measurement, requires no acid or dangerous chemicals, and generates very little waste. So when samples are injected into the combustion tube at temperatures in excess of 720 degrees Celsius, organic and inorganic nitrogen in the sample is decomposed to NO. Now with the addition of ozone, NO is even further oxidized to NO2. This NO2 is then detected by the chemiluminescence detector in the TNM unit. The theory behind this is that if the total nitrogen in the sample is less than the limit of TKN allowed, then the sample passes by default. Or labs could run a separate test to determine the nitrate and nitrite values in the sample and then calculate TKN. So TKN is equal to total nitrogen minus nitrate and nitrite. One important note I want to add is that if you already have a TOCL in your lab, this total nitrogen module can easily be added to any instrument, any existing instrument already in your lab. So in this slide, the graph on the left shows the excellent recovery rates for various nitrogen-containing compounds using the Shimadzu TNML. On the right, the graph shows a comparison of total nitrogen results between samples measured using the Shimadzu TNML, and then the same samples measured using the TKN plus nitrate and nitrite method. So as you can see, these results are virtually identical, indicating that total nitrogen module can give you the same results as running TKN plus nitrate and nitrate. So here I just want to make you aware of the various methods that can be utilized for measuring total nitrogen with Shimadzu TNML. First, on the international level, we have ISO 20236. And then on the national level, we have ASTM D8083. And also standard methods 4500-NE. So the ISO 2326 is a method for combined analysis of total organic carbon and total nitrogen. It is applicable for potable water samples, raw water, surface waters, wastewater samples. So this method is used predominantly in the environmental, drinking water, and industrial market segments. Next, we have ASTM D8083. So this describes the analysis of total nitrogen and TKN by calculation. So TKN by calculation means you have to additionally measure nitrate and nitrite, and then utilizing the total nitrogen and the nitrate and nitrite numbers, you can calculate TKN. So this method is also for water samples. It is used mainly by industries for measuring surface waters, groundwaters, and wastewaters. Next, we have the standard methods 4500-NE. This is also a method for measuring TN, or total dissolved nitrogen, and also TKM by calculation, similar to the ASTM D8083 method. So this method, like I just mentioned, is very similar to the ASTM method. However, it is mainly used by municipalities. So I know there's a lot of information to take in a short amount of time. So I just want to highlight the main takeaway points from this presentation. First of all, the TOCL increases productivity with a combination of robust hardware and all new LabSolutions TOC software. Second, the TOCL expands analysis capabilities for difficult matrices, and Shimadzu has many optional accessories for these types of samples, including suspended solid samples, high salt and high halogen samples, small volume samples, and even solid samples. And third, the TOCL with the TNML can be used to replace traditional TKN analysis with a much safer, faster, and more accurate instrumental analysis. So along with all our sponsors across the Americas, we thank you for attending our webinar today. So thank you. And at this point, I think we would like to open it up for any questions people may have.
Thank you, Keith, for the wonderful presentation. Before opening it up for questions, I would like to remind a few things to the audience. You have on the screen Keith's email and my email. Please feel free to reach out with any questions that you might have come up at a later date. Also, you have the link to our environmental website, as well as the YouTube channel, where you can find a lot of information from Shimadzu, from the TOCs and other instruments. And also, I want to remind a couple of additional things. If you miss the beginning of the webinar, don't worry about it. With the link where you register at, you can access the recording, and even if you have colleagues that didn't register before the event, they can still use it to register and access the presentation and all the other materials that we are sharing with you. Relating to the additional materials, as you've heard, Keith presented about many options that are available for Shimadzu TOC. If you want additional detailed information of the results that you can obtain with the instrument, you can download the handbook that you can access from your console. And there are the results from using the TOCL for a variety of applications. So you can find there sensitivity, accuracy, precision in different matrices, using different accessories. And of course, as I said, you can contact us again, and we'll provide additional data and information that you might be interested in. And with that, now I would like to open it for questions. If we don't address your question live during the webinar, we'll follow up by email in the next few days to send the response. So there are a lot of questions in the chat, and Keith, I'm gonna start asking you an easy one. Does LabSolutions work with all TOCLs? And I'm adding a second part to that question. Are there any differences between LabSolutions, the newest software, and the older software?
Yes, thanks. Yes, the new LabSolutions software can be used with any TOCL instrument. Additionally, what was the second part of the question, Ruth?
Is the software very different from
thank you.
the old ones?
So no, the software is not different. So if you actually use the new software, the screen in the window where you control the instrument, insert your methods, and run the instrument is very similar. It looks the same. You probably won't even notice much difference. The change is on the back end of the software is what we do with the data. So now the new software is integrated into the LabSolutions Manager for protection of your data. So all the differences will not be noticed by users.
Thank you, Keith. So someone who has been using the TRCL for a while with different versions of the software can easily upgrade to the new version because it's compatible with all the instruments, and the software itself is very similar from the user experience, correct?
Correct.
Perfect. We have another question asking about TRC, moving from the TRC-V to the TRC-L. A lot of people have been using TRC-V for a while, and they want to move to the TRC-L, to the combustion system. Is there a virtual advisor that people can use for the TRC-L?
Yeah, so correct. The TOC-V was our older model TOC. It was discontinued, I think, about 12 years ago, even though we still have many people using them. So we do have a lot of good help guides for people wishing to switch to TOC-L, including the virtual advisor, as you mentioned, at the website where you can go access help for your new instrument. We also have YouTube videos out there that will help you for troubleshooting and running your TOC-L. We have a lot of great resources.
Thank you, Keith. There were a few questions in the chat about detection limits of detection, limit of quantification for carbon and nitrogen. Could you, I know you mentioned some of them through the presentation. Could you quickly summarize what the detection limits for carbon and nitrogen are?
Sure. So I'll have to start by saying that there are actually two different model TOC-Ls. We have a high sensitivity model and a normal sensitivity model. So there's slight differences in the instrument. Obviously, the high sensitivity model is for low-level measurement. So that instrument will have a detection limit of 4 parts per billion for carbon, and I believe it's 20 parts per billion for nitrogen. The normal sensitivity instrument has a detection limit for carbon of 50 parts per billion, and I believe for nitrogen is also 20 parts per billion. So a lot of times you'll have to check because the differences in the models or even maybe some accessories you have may change the applicable detection limits. So a good place to look, as Ruth mentioned, is we have an application handbook in the links. So that is a collection of all different types of analysis using different accessories. And in there, it will show you the actual detection limits, limit of quantitation for different methods for these different configurations that you might have.
Thank you. Another question related to total nitrogen module and TRC. When running the total nitrogen and the TRC simultaneously in the same instrument, is there more use of consumables or more wear and tear on the instrument?
Oh, that's a good question. Thanks, Ruth. So the answer to that is no. Because everything is still being injected in the TOC, the total nitrogen module is just downstream of your TOC. So it does not require any additional consumables. It does not require any additional chemicals, and it does not introduce any more wear and tear on the instrument. It does allow you, like I said, to measure carbon and nitrogen simultaneously.
So basically, you get the two results based on a inline approach. You know, the two parameters are measured in line, going through the same.
Correct. So at all times, sample is flowing through both of them, whether or not you're actually reporting or recording carbon or nitrogen. Sample is still going through them at all times, so it does not increase any kind of maintenance or consumables.
Thank you, Keith. Suddenly there were a lot of questions that pop up in my screen at the same time. So I'm double checking that we are not repeating topics. Oh yeah, what's the concentration of halogens in the samples or what's the maximum concentration of halogen in the samples before having to use the scrubber?
That is a very good question. I'm not certain at exactly what level. It probably depends on your injection volume, but it's somewhere around a few thousand ppm. So somewhere around a few thousand ppm of salts or halogens in your samples are going to start having detrimental effects to the analyzer, where you would want to add these scrubbers to start scrubbing some of that stuff out. So, and the scrubbers inside the instrument, specifically the halogen scrubber, it does have indicators when it becomes consumed. So one of the scrubbers in there will change colors when it becomes consumed. And the B-type halogen scrubber, there is some stainless steel mesh in there and an acid solution. So the acid solution will also begin to change colors as it absorbs halogen. So it's very easy to tell when it's time to replace these scrubbers.
Also, there was a question, someone that doesn't have the kits for the to remove the particles, was asking what's the filter size that you recommend people to filter the samples through if they don't have any of the add-ons to minimize the problems caused by high particle samples.
That is a good question that I'm not certain I have an exact answer for.
I guess, I mean, it depends on the method.
It will depend on the method, but I mean, if there are particulates in the sample that are greater than 0.5 millimeters, they could start clogging the flow lines, right? Also, you know, if you follow some methods, you know, a lot of methods for like dissolved organic carbon, for instance. Methods to say filter your samples through a 0.45 micron filter. So that could be an option, because then at that point you're removing any particulates and just measuring what they call dissolved organic carbon. So if you have particulates maybe that, you know, you're worried about clogging, you could just measure dissolved organic carbon and filter them through 0.45 micron filter.
Good. Another question related to running samples on the TRC and the TN. If the liquid samples have some amount of acid, can they be run to the on the TRC and TN?
Yes, they most definitely can. So for some carbon analysis like NPOC, we need to add acid, right? That's part of NPOC, or non-purgeable organic carbon, where we acidify the samples to a pH of 2 or less. And any inorganic carbon in your sample at that point can be converted to CO2, and we can sparge to remove that. That will have no effect on the nitrogen measurement. So if you're technically just doing nitrogen measurement, you do not need to add any acid. The acid is for carbon measurement, or specifically non-purgeable organic carbon. So whether or not you add acid is probably more dependent on your carbon measurement, because it has no effect on nitrogen measurement.
Perfect, and that relates to another question in the chat that was asking if volatile organic matter can be analyzed with the TRCL. So as you were mentioning, there is the non-purgeable and purgeable.
Correct, it can
analysis.
Be. Yeah, it's not a very common application to measure purgeable organic carbon. We do offer a specialized kit for measuring purgeable organic carbon for labs that may need to actually measure it. That would then allow you to, say, measure non-purgeable organic carbon and purgeable organic carbon, and add those two together to calculate your TOC, right? That's not as common as the other method where people measure total carbon, inorganic carbon, and then they do a subtraction, TC minus IC equals TOC. But we do have a specialized kit for measuring actual POCs in samples or volatiles.
Perfect. But there are some very specific questions about the software in the chat, and we'll follow up with the people who send those questions via email. I'm going to ask one last question to Keith. Can you briefly explain how the high suspension kit works? The person who submitted the question is working with samples that have almost 0.4% weight of clay and sand in the samples, and they are interested in knowing more how the high suspension kit works.
Okay. So without the high suspension kit, I'll explain first. So if you're not using the kit, the instrument will pull sample into the syringe, and then sometimes it'll even pull in more sample than what it needs so it can do replicate injections out of there. But what it does is it fills that syringe with sample. Then it may rotate the valve and then inject sample into the combustion tube, right? Well, this process, there is some delay, I guess, and samples that have particularly high sedimentation rates will tend to settle out, almost instantly. So that's going to lead to biased results. So this new high suspension kit physically changes how the instrument is operating, how the syringe is working, and it uses actually a fixed sample line, a certain volume. So what happens is that, the syringe will pull in sample. So in one motion, it pulls sample into the syringe to fill this loop, and immediately then injects that into the combustion tube for analysis. So there is virtually no time for sample to fall out of solution or sediment into the flow lines or the syringe. So it gives you more accurate measurements for all these samples that have very high sedimentation rates. So it's a physical change of what the syringe is actually doing. Hopefully that helps answer that question.
Perfect. Before closing the webinar, I saw a comment in the Q&A box, going back to the question about filtering the samples. Yes, when you filter the sample, you are not doing TOC, total organic carbon. You are changing to a dissolved organic carbon type of measurement. We understand that. We were recommending a pore size to filter samples in case someone doesn't have the kit and need to run the samples and don't have any specific requirements to use standard method, ASTM method, EPA method for this application. And with this, I would like to thank Keith again for the great presentation, and thank everyone who joined us today. We have a same webinar tomorrow in Spanish if anyone wants to share the information with your colleagues, and I'll encourage you to access the resources that we provided in the console, and hopefully see you soon in another webinar from Shimadzu focusing on environmental applications. We'll be doing one on ion chromatography in the next couple of months. Thank you, everyone.